this video, we are exploring symmetry. So a transformation is a change in position, shape, or size of a geometric figure, which is a flip, slide, or turn. Line of symmetry is a line that passes through a figure so that it cuts the figure into two congruent halves. The figure is reflected across that line. So let's take a look at example 1. Find all lines of symmetry for the shapes below. So for part A, we have two lines of symmetry with the rectangle. We have an octagon in part B that have 8 lines of symmetry, one for each side if it's a regular polygon. We have no lines for part C, and the letter T has 1 line. Okay, so we've looked at lines of symmetry. Let's take a look at rotational symmetry. When a figure can be rotated less than 360 degrees, and it looks the same as it did before the rotation. The center of rotation is the point at which the figure is rotated such that the figure has rotational symmetry. And the angle of rotation is that amount of angle, usually in degrees, a figure is rotated about the center of rotation. Example 3, determine if each figure below has rotational symmetry. If it does, determine the angle. So for the pentagon, from the center I can draw 5 lines, and I can see that this cuts my pentagon into 72-degree angles, which if I rotate that, 72, 144, 216, and 288, I see I get the exact same pentagon. Part B, we see that the letter N has 180 degrees. And the square I can cut into 4 quadrants. That gives me 90 degrees. So that can rotate that 90, 180, and 270 degrees. And then the starfish is the same as the pentagon. I can take 360 divided by 5, and I can turn it 72 degrees each time, which gives me 72, 144, 216, and 288 again. Point symmetry is when a figure has rotational symmetry of 180 degrees. So in example 4, we're looking to see if we can rotate this figure 180, does it look the same as the original? So the letter H would be yes. The letter D does not have any rotational symmetry. It does have line symmetry. But it does have rotational symmetry of 120 degrees and 240 degrees. And the yin-yang in part D, if I rotate it, I get the same shape, but the colors are different. So yes for the shape, but if we're looking at the colors, they don't match. The equilateral triangle doesn't have point symmetry. On exploring symmetry, some basic ideas here. You should be ready for the practice set.